factoring polynomials, squares and square roots. Recall that 5 to the second power, or 5 squared, equals 5 times 5. So we have 2 copies of the base, and it equals 25. Our new question is, we have something squared, and we know the answer, but we'd like to find out how to go backwards and figure out what it was that was squared to give 25. So this is a square root question, and the inverse of raising something to the second power. So our square root symbol is like this and has the answer underneath. And we want to know what goes times itself or gives us 2 copies to give 25. The answer is 5. Another way we can look at it is we have the square root of something squared. The root symbol and the exponent actually cancel each other and just give you the 5. Another one we could look at is, what is the square root of x squared? So our root symbol and our exponent are going to cancel each other out because they're inverses to leave us just x. We can generate a table of squares. To generate the table, I have just taken numbers 1 through 10 and multiplied them times themselves to give x squared. Now, if I want to find a square root of something in the second column, I will just go backwards. So if I want the square root of 49, I'll just find the 49 and go backwards. The square root is 7. If I want the square root of 16, I just find the 16 and go backwards, and the square root is 4. All of the numbers in the second column are called perfect squares because they have a whole number for a square root. There are 2 types of polynomials that we can factor that have perfect squares: binomials that have a difference of squares, and perfect square trinomials.